Hey guys, it's Mrs. D, and I'm going to take a few minutes with mole conversion video number 2, and we're going to work on using the molar mass. So our goal is to go from moles to mass and mass to moles. Let's head to our little chart here. So we have Moleville in the middle, and this way, this time, we're going in the direction of moles to mass, mass to moles right over here. Whoops, hold on. So let me do a white ink on this today. We're going to look for, first of all, you have to determine the molar mass of a substance. And so the molar mass, let me show you how to do this because you can't just plug in some random numbers. You have to use your periodic table to find the molar mass. So copper hydroxide is Cu, and then we have hydroxide. And since copper has a 2 plus charge and hydroxide has a 1 minus, so we have CuOH and with a 2 on the outside. So the first thing that we do is we look to consider how many coppers that we have. And we have 1 copper. And for oxygens, we have 2 oxygens because the 2's on the outside of the parentheses. And for hydrogens, we have 2 hydrogens as well. So we need to then go to our periodic table to find the actual molar mass of copper. Now, the molar mass of copper, that's going to be the atomic mass or the average atomic mass on the periodic table. So if I go and let's see here. If I look at my periodic table here and I find copper, I'm going to find that the molar mass for copper is 63.5. So I'm going to take 1 times 63.5. The molar mass for oxygen is 15.99, so it's efficient and fine to put 16. And the molar mass for hydrogen is like 1.011, so you can just put 1. Then you add those together, so you have 63.5, 32, and 2. We're going to add all of that together to find our molar mass. So we have 2 plus 2 is 4, plus 3 is 7, and then 6 plus 3 is 97. What this means is we have 97 grams of copper hydroxide, copper 2 hydroxide, for every 1 mole of copper 2 hydroxide. That is our molar mass. If I just want to find the molar mass of copper of just 1 copper, it's going to be 63.5 grams per 1 mole of copper. So we need to be able to do this in order to go ahead and find to convert from moles to mass, mass to moles. So let's try this. First off, we want to know what the mass is of 4.32 moles of barium chloride. So we're given the mass in moles, and we need the molar mass in order to convert. So we've got to look at barium chloride first. So we have BaCl2. Okay, how many BAs do we have? And how many CLs do we have? And we have 2. Now you guys don't need to write this out every time, but I'm just writing it out the first few times just so you can see what your thinking is. You're going to get good at this and you're going to get to the point where you just punch it into your calculator, okay? But right now I'm just writing it out to show you. Now if I look at the periodic table, barium has a molar mass of 137.3. Okay, that is the atomic mass of barium. That means if I had 1 mole of barium, that's how much that would weigh. Now chlorine, if I look at chlorine on my periodic table, I'm going to find that chlorine is 35.5. So if I had 1 mole of chlorine, it would weigh 35.5 grams. Now, I'm going to multiply out. So I have 1 times this, and then 2 times 35.5 is 71. So then I add them together. So this right here is my molar mass of barium chloride. That means I have 208.33 grams for every 1 mole of barium chloride. Now I can go and do my conversion. So I look at my question, and my question is I have 4.32 moles, and I'm looking for the mass. Sorry, that's my need, is the mass. So I always start with what I have. I'm going to go back to my conversion rules. Start with what I have. So I have 4.32 moles of barium chloride. Now I'm going to go to mass of barium chloride. So I have to think about the molar mass, and molar mass is the number of grams per 1 mole. So when I have 1 mole of barium chloride, and the reason why I put 1 mole here on the bottom is because I'm catty corner, and so sorry about that. So I'm able to mark those out. Now here is where I put my molar mass. I have 208.33 grams of barium chloride for every 1 mole. So my moles cancel. I'm left with grams of barium chloride. That's what I need is mass. So I multiply across the top, multiply across the bottom, divide the two. Well, it looks like across the bottom there's just 1, so I don't need to divide by anything. So I'm just going to multiply across the top. So I'm going to take 4.32 times 208.33. And I want to think about sig figs here. So ultimately there's 3 sig figs here in 4.32, and there's 5 here. So when we multiply, we keep the lowest number of sig figs. So my number is 899.9. So I want to go with 900. I mean, officially it's going to be 900 point because you'd have 3 sig figs, but typically you can do plus or minus 1 sig fig. So it might be 900.0. And that is grams of barium chloride. Okay, that's the number of in 4.32 moles. Let's try another one. How many moles is 402 grams of calcium carbonate? So now we're going and from grams of calcium carbonate and we're going to moles. So we have grams and we need to determine moles. Okay, but we have to do something before we go any further, and that is find out for calcium carbonate. So calcium has a 2 plus charge, carbonate has a 2 minus charge, so therefore we're good with CaCO3. So we have in CaCO3, we have 1 calcium, we have 1 carbon, and we have 3 oxygens. Now if you look at calcium, calcium weighs 40 grams approximately, and carbon weighs 12 grams. And I'm getting this from my periodic table, the average atomic mass on my periodic table. So I have 40 plus 12, and then 3 times 16 is 48. So if I add all those together, I'm going to get a nice even 100 grams. How beautiful is that? So now I need to convert, and I have 402 grams of calcium carbonate, and I want to determine the number of moles. So since grams is on the top, I need grams on the bottom of my next one so I can cancel. So my grams comes from my molar mass, which is 100 grams of calcium carbonate for every 1 mole of calcium carbonate. So my grams can cancel, and I'm going to end up with moles as my answer, which is what I want. So I take 402 times 1, which is 402, divided by 100. So if I take 402 divided by 100, I'm going to get 4.02. Now, look, 402 has 3 sig figs, 100 only has 1 sig fig. So it is fine for me to express my answer instead of 4.02 into just 4 moles of calcium carbonate. So that means 402 grams of calcium carbonate is equivalent to 4 moles of calcium carbonate. Now, I want us to go back and just recognize what we did here. We went from moles, sorry about that. We went from moles to grams and grams back to moles. And the vehicle we used was the molar mass. So before you can do these problems, you have to calculate the molar mass. You guys got this, and the next unit or the next video is about molar